I welcome you to Global Case online lesson. My name is Salami Sodiq Adirotimi, your chemistry teacher. Today we want to be looking at transition state theory, a subtopic under rates of chemical reaction. In our previous lesson, we look at the rate of chemical reactions, we look at collision theory and factors affecting collision theory. So today we will continue from where we stopped, transition state theory. Transition state theory is also known as activated complex theory. So this theory is concerned with what happens to the reactants when they are about to form a product. The theory is all about reaction mechanisms, that is, the phases of reactions. And this reaction, we are going to look at it now. Consider this reaction where we have a reactant A and reactant B colliding together and form M star. This M star is the activated complex. What this reaction is talking about is that for every collision between reactants A and B, they will not form product directly. What will happen is that they will first of all form an activated complex before decomposing to product at definite rate. So every reaction has an intermediate. Activated complex is an intermediate reaction. And from what we learned last week, we learned that it's not all collision that can result to the formation of product. And that is the reason why this reaction cannot automatically lead to product. Why? Because there are some factors that must be put in place. Now, the first factor, look at it, is the frequency of collision, as I've said in our previous lesson. And the second is the energy of the reactant exceeding activation energy. Now, the summary of this theory is that molecules undergoing reactions will first of all form an activated complex which is in thermodynamic equilibrium with the reactant. You can see that the activated complex is in equilibrium with the reactant. Why? It's because if the energy of reactant did not absorb adequate energy to overcome the barrier posed by activated complex, it can bounce back, and that is why it is in equilibrium. That is, you can have it in the forward reaction like this, and M star can decompose back to the reactant if sufficient energy is not supplied. Also, look at this. The overall equation is that reactants undergoing reaction must first of all form an activated complex in thermodynamic equilibrium with the reactant before decomposing to product at a definite rate. So it therefore implies that every reaction must follow this theory. Every reaction that can lead to formation of products must obey activated complex theory. So it's a theory that summarizes the mechanism of reactions and to let us know that every reaction has an intermediate. There is an intermediate before you can get a product. So no reaction is automatic. There is no automatic reaction from reactant to product. it must follow the activated complex theory. And also, let's look at factors affecting rates of chemical reaction. We have 5 factors affecting rate of chemical reaction. The first one is the nature of reactants. The second is concentration and pressure. The third one is surface area of reactants, followed by temperature change, and finally, effect of light. The first one, nature of reactants. This means the form or state of reactants. Now, recall that reactants is either in liquid form, in solid form, or in gaseous form. So, if you are working with gaseous reactants, the rate of reaction tends to be faster than working with liquid reactants. And also, the rate of reaction for solid reactants tends to be slow. So when you have solid reactant, you cannot compare the rate of reaction of a solid particles with that of liquid. So I wrote here that gaseous reactant work faster than liquid, and liquid also react faster than solid. Now, let's look at concentration. Number 2, concentration and pressure. Since the rate of reaction depends on the rate of collision of reacting particle. Now, increase in concentration will definitely make the reacting vessels more crowded with particles. Therefore, collision will increase. Now, in every chemical reaction, concentration is directly proportional to the rate of chemical reaction. Increase in concentration always increases the rate of chemical reaction. How? Because when the concentration increases, the molecular collision tends to increase. And when the frequency of collision increases, automatically the rate of chemical reaction will increase at definite rate. Then the third is surface area of reactants. For reactants to react, the surface of the reactant particle must be in contact. So, the greater the surface area, the faster the rate of reaction. Now, with this surface area, I would like to carry out a simple experiment on the effect of surface area of reactants. We are going to consider 2 things here. This is calcium hydroxide. We will look at dissolution of calcium hydroxide. Also, I also have a base here, sodium hydroxide. So we will look at the solution of sodium hydroxide. Now let me start with calcium hydroxide. Calcium hydroxide. So this is a base, calcium hydroxide. Now we will dissolve it in water and we'll look at the rate of reaction. Of course, it will react when this dissolved completely in water. We will also compare the same reaction with dissolution of sodium hydroxide. Now look at it. Now, This is sodium hydroxide. This is a pellet of sodium hydroxide. You can see the nature now. The nature of this reactant, pellets. Now, let's compare it. Look at the two. This is in powdered form, and this is the pellet. Now, this one, the pellet, has a small surface area. What do we call surface area? Surface area is the total area occupied by the sample. So the surface area is small. Compared to this, you can spread it over. You can see that it has a large surface area. I'm talking about this powdered calcium hydroxide compared to pellets. Now, what we want to affirm is that reactant with small surface area dissolve faster with the one with reactant with large surface area dissolve faster in water than the one with small surface area. Now, I have water here. Let me quickly dissolve them. Just pick you can see a white solution. So it has dissolved to form a white solution. Now, if you look at the reaction is very fast, almost instantaneously. So the reason is because of the large surface area of the reactants. Now, let's now compare this with the pellet of sodium hydroxide. Now, this is the pellet of sodium hydroxide. Do we also need a steering rod to have a complete dissolution? So as you can see, it's taking my time. So this tells you that the larger the surface area, the faster is the rate of chemical reaction. And then the lower the surface area, the slower is the rate of chemical reaction. You can see, we still have a pellet inside. It will dissolve with time. It will dissolve. It's just to show you that when the surface area is small, then the rate of reaction tends to be slow and vice versa. Okay, the fourth one is temperature. Generally, for every 10 degree rise in temperature, the rate of reaction tends to be doubled. So, increase in the rate of reaction due to temperature changes occur in two ways. And then the first one is according to the kinetic theory of gases, the fifth law, that says that absolute temperature is directly proportional to the average kinetic energy. So the first one is that increase in temperature or heat energy increases the kinetic energy of the particles. And the second point is that when temperature increases, the number of particles that will have energy equal or higher than the activation energy increases. What they are talking about here is that, let me refer you back to the previous lesson, where I said that for a collision to be effective, the energy of reactant must be greater than the activation energy. So the second point is that the energy absorbed by the reacting particles must be greater than the activation energy. So at that point, the rate of chemical reaction tends to be faster. Now, generally, we can generalize the effect of temperature on this theory. Increase in temperature will definitely increase the rate of, the kinetic energy of the particles. And when the kinetic energy increases, the molecular collision increases. When the molecular collision increases, the frequency of that collision tends to increase and then leads to what? Increase in the rate of chemical reaction. Then the fifth one, effect of light. Effect of light. Some reaction will only occur in the presence of sunlight. Some reaction occurs in the presence of sunlight. It therefore means that sunlight is acting as a catalyst or as an initiator for some reaction to take place. For example, let's look at the reaction of hydrogen and chlorine. Reaction of hydrogen and chlorine takes place in the presence of sunlight. That is when they must have absorbed sunlight, that is radiation, in order for that reaction to be initiated. And then popularly, we are familiar with photosynthesis in biology. It's the process by which green part of plant manufactured their food. Now there are requirements, and then part of the requirement is sunlight. So sunlight is a necessity for photosynthesis to take place. Now it cannot happen in the dark. So in the dark reaction, photosynthesis cannot take place. Also, in organic chemistry, chlorination of methane is a reaction that takes place in the presence of sunlight. So, generally, every reaction initiated by sunlight or by radiation, such reaction is known as photochemical reaction, or we call it photocatalytic reaction. Why? Because the reaction is being catalyzed by sunlight. So we have discussed 5 factors that affect the rate of chemical reactions, and these factors are very, very important. It determines how fast or how slow the rate of reaction will be. I think you can begin to apply this into some of the reactions that you know. It will tell you whether the reaction will be fast or will be slow, considering the factors listed here. So we have come to the end of this lesson today, and I have an activity for you. I would like you to explain the collision theory of gases and discuss the factors responsible for effective collision. Explain the collision theory of gases and discuss the factors responsible for effective collision. I remain Salami Sodiq Aderotimi.